Hello everyone, I am Barik from National Tsinghua University, and I am very pleased to present my work in the Mark Young Scientist Award Competition 2025. And the topic of my presentation is gold catalyzed and metal-free cascade annulation for the synthesis of highly functionalized organic frameworks. So let's start with the importance of the gold catalysis. So before, gold was considered as a catalytically inactive metal, but due to its soft Lewis acid character, so it is now a powerful tool and a key in the pi activation chemistry, mainly for alkynes and alkenes. So its mild, tunable and selective nature makes it a valuable catalyst in the modern organic synthesis. So our work introduced three new gold catalyzed cascade annulation reactions, where in the first case we achieved a 4+2 annulation between the terminal alkynes and nitrones, producing biologically important quinoline scaffold. And in other work, we develop a new strategy where the alanines and nitrones generate the synthetically important 1,3-dipolar intermediate, which further undergo a 3+3 annulation to give two regiocontrol eno-functionalized product. And in the recent work, we explore a diazo-diazo cross-coupling reaction that afford two different chemoselective products, and I am going to briefly discuss this work in this presentation. So here basically the two diazo compound first form an isolable intermediate 3, which further gives two chemoselective product depending on the reaction condition. And a key step involves a Wolff rearrangement of alpha aryl diazo compounds generating a ketene intermediates, which reacts with the another diazo species to produce this intermediate 3. And then in presence of gold catalyst, this intermediate 3 cyclized to give cyclopentenones, and under the metal-free condition, by using the tetrabutyl ammonium fluoride, it instead yields the pyrazole derivatives. So both the cyclopentenones and pyrazoles are biologically relevant, and notably these transformations can be conducted in both sequential and one-pot protocols as well. So here we highlighted a few selected examples of bioactive compounds containing cyclopentenones and pyrazole cores, indicating the medicinal potential of our synthetic target. And then based on these optimal conditions, we export the substrate scope for these cross-coupling reactions. And here we demonstrated several examples of cyclopentenones and pyrazoles with the different functional groups. And along with this, here we perform several valuable synthetic applications of our obtained products. So initially we carried out the scale-up reaction for both pyrazole and cyclopentenones, and then we did the carbonyl group reduction and the sellyl protection of the cyclopentenone derivatives. And next we carried out the transesterifications, isomerizations and the methylation of our pyrazole products. Thank you for your kind attention.